So in continuation with the previous class, next is the internal rate of return, which is IRR, and it is best known and widely used for the rate of return method. It is also known as the true rate of return method and the discounted cash flow method. So the internal rate of return, it is represented by I in the traditional interpretation of interest rates, and it is the rate of interest that is being earned by the alternative investment on the unrecovered balance of an investment. So the internal rate of return IRR can be calculated by equating the annual present or future worth of cash flow to zero and solving for the interest rate IRR that allows the equality, and then it should be added and that should be solved for the interest rate in this manner. And this results in a polynomial equation that is a function of I, which may result in multiple roots of the equation. In such cases, the IRR may or may not be one of the equation roots. Although both the EAW and FW approaches are legitimate, that is genuine, the rate of return is often defined in terms of present worth under the constraints of possible I roots, where the IRR is the interest rate at which the present worth of the cash flow of a project is zero, or to restate this in another way, the rate which when employed in computing the present worth of all costs and present worths of all returns will make them equal. Because of the rate of return computations usually begin with a problem expressed in terms of present worth or annual worth, and it is necessary to pay attention to the guidelines for the EAW and PW methods. So in particular, mutually exclusive alternatives where selection of one precludes selection of others, it must be compared on the basis of equivalent outcomes. So in the case of independent alternatives, the choice of one does not affect the choice of another, except for limited capital availability. All costs and benefits must be explicitly stated. Calculation of IRR. Determining the IRR, it is a function of the type of investment, that is simple, pure and mixed, and the characteristics of the alternatives, that is being mutually exclusive or independent. If we have independent projects, we may fund combinations of the project, since an independent project does not affect the funding of another project except for capital availability limitations, which are very real in most situations, and it is being analyzed by the engineering economist. So the cash flows of several independent alternatives that are being considered as a group may be summed to form the group's composite cash flow. So analysis can then be performed on this composite cash flow, where capital limitations are apparent in a department and several independent alternatives are competing with each other for funding, and combinations of alternatives may be formed where each combination's first costs have to be equal to or less than the capital available. So in this case, mutually exclusive combinations will usually be realized where selection of one group of independent alternatives will preclude the selection of another. So this can be due to alternatives being in more than one group and or capital limitations. So we will see that ranking alternatives according to IRR values is not consistent with the PW, FW or AW rankings, and mutually exclusive alternatives may be analyzed by incremental IRR analysis, and the results will be found to be completely consistent with the PW, FW and AW methods. So incremental analysis assumes that we start with a satisfactory low investment alternative. So analysis of a higher investment alternative is then based on the differences between the cash flow of the second alternative and the acceptable alternative. So these differences in cash flows are incremental cash flows, and the cash flow of the second alternative is equal to the cash flow of the first alternative plus the incremental cash flow. So thus if the incremental cash flow it is acceptable when compared to MARR, then the larger investment has to be in a better investment than the first alternative, which was also acceptable. Otherwise, we have to remove the larger investment from the consideration, and this type of evaluation is continued until all alternatives have been evaluated. One of the mutually exclusive alternative is then determined to be the best investment. As mentioned earlier, there is a possibility that the PW equation may be a polynomial in terms of I, such that multiple roots, that is I of polynomial PWI, may result. Often multiple i's are assumed to be multiple IRR values, and this is misleading since there is really only one true IRR of an investment, and so we will need to determine which I or which polynomial, if any, is the investment for IRR. So classifying investments into simple and non-simple investments, it will tell us if just one polynomial exists, in turn tells us that we have found the IRR, we have found I. So an investment is simple if there is only one cash flow sign minus to plus from period to period. Cost benefit analysis. The question to which cost benefit analysis addresses itself is whether it is socially desirable to undertake a number of investment projects, for example A, B, C, D, etc. And if investable funds are limited, then how many of these should be selected? So since the choice involves maximization, we have to discuss what it is that investment planners wish to maximize. In general terms, an investment planner wants to maximize definitely the present value of all the benefits which has been less of all the costs, so subject to specific constraints. So this general formulation raises the following specific questions, the answer to which provides the general principles of cost-benefit analysis. In project appraisal, which costs and which benefits are to be considered, how are these costs and benefits are to be valued, how can profitability of a project be measured, what is the relevance of uncertainty in project appraisal, and what are the relevant constraints. So there is certainty, some arbitrariness in the choice of these questions. So in evaluating these 5 points, in a private organization, the criteria is to select the alternative with the maximum profit. So the profit maximization is the main goal of private organization, definitely. In the same time, while providing goods and services as per specifications to their customers. But the same criterion cannot be used while evaluating public alternatives. Example of some public alternatives are constructing bridges, roads, dams, establishing public utilities, etc. The main objective of any public alternative is to provide goods services to the public at a minimum cost. And in this process, one should see whether the benefits of the public activity are at least equal to its cost. So if it is, then the public activity can be undertaken for implementation. Otherwise, it can be cancelled. So this is nothing but taking a decision based on cost benefit cost ratio BC, which has been given as BC ratio or benefit cost ratio, which is equal to equivalent benefits by equivalent costs. So these benefits may occur at different time periods of the public activity, and for the purpose of comparison, these are to be converted into a common time base, present worth or future worth or annual equivalent. Similarly, the cost consists of initial investment and yearly operation and maintenance costs. These are to be converted to a common time base as done in the equivalent benefits. Now, the ratio between the equivalent benefits and equivalent costs, it is known as benefit cost ratio in a definition, and if this ratio is at least 1, the public activity is justified, otherwise it is not justified. That is, BP is equal to present worth of the total benefits of BF, that is the future worth of the total benefits. BA means annual equivalent of the total benefits. P is the initial investment. PF is the future worth of the initial investment. PA is the annual equivalent of the initial investment. C is the yearly cost of operation and maintenance, and CP is the present worth of yearly cost of operation and maintenance. And finally, CF is the future worth of yearly cost of operation and maintenance. So BC is the summation of the following 3 values: BP by PP plus C, BF by PF plus CF, and BA by PA plus C. Next is depreciation analysis, and depreciation means the decrease in the value of physical properties with the passage of time and use. Most assets are worthless as they age, definitely, and production equipment gradually becomes less valuable through wear and tear. So this lessening in value is recognized in accounting practices as an operating expense. So instead of charging the full purchase price of a new asset as one-time expense, the outlay is spread over the life of the asset in the accounting records. So annual depreciation deductions are intended to match the yearly fraction of value used by an asset in the production of income over the asset's actual economic life. So the actual amount of depreciation can never be established until the asset is retired from service life. Depreciation can be defined in three senses like physical depreciation, which is caused due to physical decay, economic depreciation, which is the loss or value of an asset due to outdated technology, and in accounting sense, depreciation is the estimated value of fall in the worth of an asset. So in accounting, depreciation charge is included in the cost of production of the asset. Depreciation is a permanent, continuing and gradual shrinkage in the book value of a fixed asset. Different causes of depreciation are physical depreciation, that is resulting in physical impairment of an asset, and this type of depreciation results in the lowering of the ability of a physical asset to render to its intended or proposed service. So the primary causes of physical depreciation are deterioration due to action of elements, which includes corrosion of pipe, rotting of timbers, chemical decomposition, wear and tear charges, physical decay, and time factors. Next is the functional depreciation. So functional depreciation results not from a deterioration in the asset's ability to serve its intended purpose, but from a change in the demand for the services it can render. The demand for the services of an asset may change. It is more profitable to use a more efficient unit. There is no longer work for the asset to do, or the work to be done exceeds the capacity of the asset. Third one, technological depreciation. Due to the advancement of new technology, old technology becomes outdated, so it loses its value. So obsolescence resulting from the discovery of another asset that is sufficiently superior to make it uneconomical to continue using the original asset. So assets also become obsolete when they are no longer needed. Number 4, depreciation due to accident. Sometimes due to accident or sudden failure, the asset loses its technological characteristics inherent or incorporated in it. Number 5, depreciation due to depletion. Consumption of an exhaustible natural resources to produce product or services is termed as depletion, and removal of oil, timber, rock, or minerals from a site decreases the value of the holding. So this decreases is compensated by a proportionate reduction in the earnings derived from the resources. Number 6, monetary depreciation. It is a change in the price level, and it also decreases the value of the assets that has been owned. So if price rises during the life of an asset, then comparable replacement becomes more expensive. This means that the capital recovered will be insufficient to provide an adequate substitute for the worn out or torn out asset. Number 7, depreciation due to time factor. There are some assets which loses its value over a particular time period. So particularly the assets having lease or copyrights and patents right loses its value after the time is over. Number 8, depreciation due to deferred maintenance. Sometimes the loss of value of asset begins very quickly due to no maintenance or less maintenance. So if proper materials are not used or instructions to operate the machine are not properly obeyed, the loss of value starts. Number 9, depreciation accounting. So before going to the different methods involved in the calculation of depreciation, we should have sufficient knowledge about the depreciable property. So depreciable property is a property which can amortize or depreciated or gets lowered or deducted. Depreciable property may be tangible and intangible. So tangible property is any property that can be seen or touched. Intangible property is a property which are not tangible like copyrights and patent rights. Depreciable tangible property is of two types, real and personal. Personal property is those property which is not a real estate, but they are machinery and equipments, and real property is land and anything that is erected on, and land is never depreciable. So property is depreciable if it fulfills the following requirements. Property must be used in business or help to provide income. Property must be something that wears out, decays, deteriorates, becomes obsolete, or loses value from natural causes. It must be determinable life, and that life must be longer than 1 year. So in general, if property does not fulfill the above conditions, it can never be regarded as a depreciable property. So next, we'll start the next unit tomorrow, not tomorrow, day after tomorrow. So you can give your attendance in the chat box now. Thank you.